Welcome to Techie Time. Today we are going to see Hamming code experiment, error detection and error correction. Hamming code is used to correct it can identify and correct one bit error. So consider we have a data m of any length. The parity or redundant bit has to be added. The values are, it depends on the value of m. To find r, 2 power r, the formula is 2 power r must be greater than or equal to m plus r plus 1. The sender will send the data m plus the parity bits r. M plus r is the data transmitted in the sender side. R is placed in powers of 2. So the positions of r can be either in 2 power 0, 2 power 1 or 2 power 2. That is positions 1, 2, 4 like that. So take for example our data is 4 bits. M is equal to 4. So R must be equal to 2 power R must be greater than or equal to 4 plus R plus 1. So this value will be true for R is equal to 3. So the number of redundant bits to be added is R is equal to 3. Total 4 plus 3, 7 bits will be transmitted from the sender side. Data should be in either even or odd parity, which we can decide. Total number of ones, if it is even, the parity value is 0. If it is odd, the parity value is 1. Now we'll consider even parity. Take for example, our data is 1001. So the data is 1001. It has 4 bits. 4 bit data, the number of redundant bits is 3. So R is equal to 3. So the length of the data is m plus r, 4 plus 3, 7. So the positions of the data are 1, 2, 3, 4, 5, 6, 7 like that. So we have seen r must be placed in 1, 2 and 4th positions. 1, 2 and 4th positions r are placed. So the possible binary representations for this P4, P2 and P1 are these. 001 represents 1, 010 represents 2, like that till 111. So P1 when the last bit, so when this last bit is 1, P1 values are 1 here. So here it is 1, last bit is 1 in 3rd position, 1st position, 5th and 7th. So my 1st, 3rd, 5th and 7th positions, the P1 last bit is 1. So we don't know the value for P1, but 3, 5, 7 values. 3 value is 3rd position value is 1, 5th position value is 0 and 7th position value is 1. So P1, 1, 0, 1. So we have considered even parity. We already have 2 number of ones here. Even number of ones are there. So P1 value is equal to 0. Now P2, the second bit position values are 1 in position number 2, 3, 6 and 7. Right? And so P2, 3, 6, 7 values are 1, 0 and 1. Here again 2 number of ones are there. So even parity. So P2 is equal to also 0. Now P4, this bit position 1. So the positions are 4, 5, 6 and 7. So P4, 5, 6, 7 values are 0, 0, 1. P4, 0, 0, 1. We have only one number of 1. So odd parity here. We have considered even parity. So the P4 value must be equal to 1. So P4, P2 and P1 values are 1, 0 and 0 respectively. So this data, now we replace this P4, P2 and P1 value. So it is 1, 0, 0, 1, 1, 0, 0. So this is the data being transmitted from the sender side. All these calculations are done in the sender side. The sent bit is 1001100. Now consider the received data as this one. So in this bit, 6th position bit, we have actually 0 but received as 1. So that is one bit error. So on the receiver side, the same calculations are done. P1, P2 and P4. P1 values are the last bit 1, so it is 1357. P2, 2367. So same calculations we do in the receiver side. The values we have received. So P1357 values are 1 is 0, 3 is 1, 5 is 0 and 7 is 1. So 0, 1, 0, 1 even parity. P1 is 0. P2 2367 values. So 0, 1, 0, 1. So again odd parity here. The odd number of ones are there. So P2 is equal to 1. P4, 4, 5, 6, 7 values 1, 0, 1, 1 we get odd parity. So P4 is equal to 1. So if there is value with 1 means there is error. If P1, P2, P4 values are 0, no error is there. So now P4, P2, P1 value is 110 which we have calculated in the receiver side. Convert this 110 to decimal, we get 6. So 6th bit is error. So the 6th bit here it is 1. So change it to 0. If it is 0, change it to 1. Now we get 1001100 which is the same as the cent bits. So now we do the same calculation. We get P4, P2, P1 is equal to 000 which means no error is there. So for our experiment we'll consider this data 1010, 1011, 0011, 1110. So we have opened the IIT Bombay virtual lab. Go for error detection and correction using Hamming code. Simulation. Click for the simulator. So in modulo 11 arithmetic we use only the integers in the range. 0 to 10 is the answer. We get correct answer. In modulo 2 arithmetic we use only 0 and 1. Enter the 4-bit data. These are the 4-bit data we are going to enter. 1 0 1 0. The next data is 1 0 1 1. Next data is 0 0 1 1. Next data is 1 1 1 0. Find the even and odd parity for the following bit sequence. So if the number of ones are 4, so even number of ones, so even parity is 0 and odd parity is 1. At what locations are parity bits located in the Hamming code word? It is 2 power nth position. So now enter the minimum number of redundant bits to be added. So 4-bit data, the redundant bits to be added is 3. Now which positions the even parity redundant bit. So if these are in position numbers, what we have seen is 1, 2 and 4. So 1, 2 and 4 are the parity bits. The remaining are the data bits. Correct answer. Now what we are going to do is with this data we are going to do the calculations. 1, 2 and 4 are the parity bits and the remaining M3, M5, M6, M7 are the data bits. So we have it in positions 0, 1, 2, 3, 4, 5, 6. The data are 0, 0, 1, 0, 1, 0 which we have here. We have here, no? These data are placed here in this table. So now the data which I have entered 1010 is the first data. It's here 1010 is the first data. Like that I have given the data here. We need to calculate the redundant bits. So now for the data, first data 1010, 1 in the LSB bit, even parity is considered. So C1 for 1 in the LSB bit, C1, M3, M5 and M7. So C1, M3, M5, M7 values are 1, 0 and 0. So this has odd number of 1. So C1 value is 1. The next has 110, even number of 1. So C2 value is 0. The next has odd number of 1. Only 1 is there. So C4 value is 1. So 101 is the value for C1, C2 and C4. Okay. Same way the calculations are done for the second data, third data and the fourth data, and this table is filled. These red color values I am going to fill here. So the first data is the data which C1, C2, C4 values which we have got there. So it is 101 is the first data. 101 is the first data which I am going to enter here. 101. The second data is 0, 1, 0. Third data is 1, 0, 0. Fourth data is 0, 0, 0. And submit. The received code word 100 spot. So we go for that. The first code word received is this one. We actually have here is this one. So we'll compare so this one is received first and this one is the transmitted. This table 1 is the transmitted 1, 0. So this bit is different, I can see 1, and this bit is also different, and this bit is also different. So we have more than one bit error, which I put here, error of more than 2 bits. The received code word, the second code word received is this one. So second received is this one. Second transmitted is this second row. So we'll compare both the data. So 0, 1, 1, 0, 0, 1, 1. So no error is there. So no error I'm giving here. The third data received is this one. So we'll compare here. Okay, the third data transmitted is this class B4 row. Copy that, paste it here. Compare both the data, 1 or zeros and last two ones. So again, there is no error. Correct answer. The last code word received is this one. So fourth received is this one, to be compared with the last transmitted data, which is the last row. So 0, 0, 1, 0, 1, 1, 0. Again, no error is there. So given no error. The received code word first and corrected is 1001100, the first one, right? So when corrected is 10 this data. So we'll paste it there. Wrong answer. 1001100. So continue till we get the correct answer. It would show correct answer and complete it. So this is how to do the Hamming code experiment. Thank you.